Okay, so in this lesson, we're going to factor polynomials by grouping. And basically, when you're going to factor by grouping, for our situation, you're going to have a polynomial with 4 terms, 1, 2, 3, and 4. So it's important that you recognize your terms. My first term is a positive 10ab, my second term is a positive 15b, my third term is a positive 4a, and my fourth term is a positive 6. And so when you, and this polynomial can be factored. Remember when we talk about factoring, we're discussing the fact that you want to write it as a product. So you want to write this polynomial as a product, some polynomial times some polynomial. So it has to look like this. So you want to get this to look like this. So you have some expression in here times some expression in here. That's going to be the idea. Well, so when you have 4 terms and you want to factor by grouping, the first thing you do, just like you did in a previous lesson, was you have to factor out the GCF first. That's the first thing. So if I look at all these 4 terms, the GCF of these 4 terms is 1. That's the GCF. So the largest factor that these 4 terms have in common is 1. Now, if it was something other than 1, you would factor it out, and then you would go further. So that's going to be a situation later on. Okay, so since the GCF is 1, the way you want to approach this to make it look like this is we're going to group the first 2 terms and we're going to group the last 2 terms. And when I group the first 2 terms, as such, this sign right here is going to be important at some point. So either this sign right here is going to be a positive symbol or it's going to be a negative symbol. Okay, so the way you want to approach this now is this when you factor by grouping. Let's go ahead and cover that second group, and then we're going to ask ourselves, just as before, if all I had was this polynomial right here, what's the GCF? Well, you can look at this and see that the GCF, the greatest common factor that 10 and 15 have in common is 5. And then for A, B, and B, the variables, the greatest common factor is B. So I can factor out from this group right here, I can factor out 5B. And so when I factor out the 5B, I'm going to get 5B times, let's see, that's going to be 2A, because 5B times 2A is 10AB. So remember, we're using the distributive property. Plus, and then 5B times 3 is 15B. 5B times 3 is 15B. All right, so that's what I get here. Now, if we go to the second group, this sign right here is going to be important. So I want to factor out a positive GCF. And so if we look at these 2 terms, 4a and 6, the GCF of 4a and 6 is 2. So I can factor out a positive 2, and then I'll do the same thing. 2 times 2a is 4a, plus, and then 2 times 3 is 6. Now, if this is factored by grouping, and for us, it's going to turn out where you're going to group the first 2 and the last 2. There are situations where we could have that the first 2 and the last 2 groupings wouldn't work. We would have to switch some terms around. But for us, at this point, we're going to group the first 2, we're going to group the last 2. If this is factorable by grouping, then these 2 groups here, this group and this group, should have a common factor in parentheses. So then I'm going to factor this out. So when I factor this out, I'm going to get 2a plus 3. So basically what I'm factoring out is this. 2a plus 3. And when I factor out the 2a plus 3 from this group, you're left with 5b. Notice the parentheses are important. So you got to have the parentheses here. You got to have it look like this. And then if I factor out the 2a plus 3 here, I'm left with plus 2. And so this would be your factorization. So you factored this polynomial as a product of factors. Now always make sure, because you could have made some kind of error at some point. Well, maybe not an error, but if the GCF was something other than 1 and you didn't factor out the GCF first, then at this point, you would recognize that, hey, the GCF is not 1 but something other than 1. Because if I look at this factor, the GCF is 1 of these 2 terms. If I look at 5b and 2, the GCF is 1. Okay, so originally the GCF was 1. Okay, number 2, again, you want to make it look like this. You want to factor this polynomial by grouping, and so you want to eventually make it look like this. That's the idea with factoring by grouping. So number 2, I have 8xy minus 4y plus 6x minus 3. All right, so I have 4 terms. You need to recognize your terms. My terms are 8xy, a negative 4y, a positive 6x, and a negative 3. Those are my 4 terms. So don't say the second term's a 4y because it's not. It's a negative 4y. You got to get the sign. And the last term is a negative 3, not a 3, but a negative 3. So I have 4 terms. If I look at all these 4 terms, the GCF of all these terms, all the terms don't have the same variables in it. If I look at 8, 4, a negative 4, 6, and negative 3, the GCF is 1. You can look at all 4 terms at the same time. So the GCF here is 1. So since the GCF is 1, I'm not going to factor out a greatest common factor. So now I'm going to go directly to grouping. So I'm going to group the first 2, and I'm going to group the last 2. If I group the first 2, and again, it may help if you cover that second group so you don't have it visually. So if we group the first 2, the GCF of this group, so if you look at 8 and negative 4, the GCF is 4. And if you look at these, the variables, they have a y as a factor. So the GCF is 4y. So that's your GCF. And so I'm going to factor the GCF out. So I get 4y times 2x. 4y times 2x is 8xy. Minus, and then 4y times 1 is 4y. So you need that 1 here. Okay, now let's go to the next one. So remember, you got to factor out that positive sign right here. So if we look at these 2 terms, I'm going to factor out a positive 3. And then when I factor out a positive 3, 3 times 2x is 6x. And then 3 times a negative 1 is a negative 3. Now, notice that these 2 groups right here, these 2 groups that I was working with, they both have 2x minus 1 as a common factor. So now you just factor that out, 2x minus 1, and when I factor out 2x minus 1, cover it up, and so you have 4y. And if I factor out that 2x minus 1, I get a plus 3. All right, now always double check your factors. Is 2x minus 1, look at 2x minus 1, you make sure that GCF is 1. So the greatest common factor of 2x and a negative 1 is 1. And same thing here. The greatest common factor of 4y plus 3 is a 1. All right, so that implies that this was correct. You made that correct assumption earlier. So there's your answer. So you wrote this as a product of factors. And each of those factors, the GCF is 1. Okay, number 3. Suppose in number 3, I had 6x cubed minus 15x squared plus 2x minus 5. All right, so 6x cubed minus 15x squared plus 2x minus 5. All right, so again, if you look at the 4 terms, 6x cubed, a negative 15x squared, 2x, and a negative 5, the GCF of all 4 terms is 1. So now, since this is a polynomial with 4 terms, I'm going to try factoring by grouping. So I'm going to group the first 2, and I'm going to group the last 2. From the first group, if you look at the first group, they have, for 6 and negative 15, we have a 3 in common. So that's a GCF, and then x squared. So the GCF is 3x squared, and when I factor out the 3x squared, I get 3x squared times 2x. 3 times 2 is 6. X squared times x is x cubed. Minus, and then 3 times 5 is 15. And I've already factored out all of my x factors of x's. So that's just 5. So 3x squared times a negative 5 is a negative 15x squared. Now if I go to that next group, remember you're going to factor out that sign right here. So you're going to factor out a positive. So you have to have something listed there. It's got to be a sign right here. So you're going to factor out a positive. Now if you look at 2x and a negative 5, the GCF is 1. So you got to say I'm factoring out a GCF of 1. And then when I factor out the GCF of 1, 1 times what is 2x? Well, 2x. And then 1 times what is a negative 5? Well, minus 5. Now again, if you look at those two groups, so I factored each group, but remember you want to factor the original polynomial. So if you look at these two groups, they have a factor of 2x minus 5 in common. So you factor that out. So I get 2x minus 5. So you're always going to end up with these factors being the same. If they're not the same, then you did something wrong, or you didn't use the greatest common factor of each group. You may have used a common factor, but not the greatest. You have to use the greatest. So if I factor 2x minus 5 from this group, I get 3x squared, so you put that in parentheses. And if I factor 2x minus 5 from that group, I get plus 1. And notice that you always go back and double check your factors, make sure the GCF of each of those is indeed 1. So this GCF of 2x and negative 5 is 1, and the GCF of 3x squared and 1 is 1. All right, so that's what we get here. Okay, now let's look at number 4. So number 4, we have 12xy minus 28x minus 15y plus 35. Now we're getting to a situation where, remember right here, so that was an addition symbol, so I factor out a positive GCF from this group. I factor out a positive GCF from this group. I factored out a positive GCF from this group. Now this is a negative, so when I get to this point, I'm going to factor out a negative GCF from this group. Okay, so let's group the first two. Well, first of all, the GCF of all four terms is 1. All right, so 12xy, negative 28x, negative 15y, positive 35, the GCF is 1. So since the GCF is 1, I'm going to go directly to grouping the first two and then grouping the last two. Okay, when I group the first two, again, you got to look for the GCF of that group right here. So the GCF here is 4x. That's your GCF, 4x. So I'm going to factor out the 4x. Always factor out the GCF. When I factor out the 4x, remember you got to use the greatest, because if you don't, then these parentheses you're going to end up with won't have the same factor. Okay, so the GCF is 4x. So when I factor out a 4x, I get 4 times 3 is 12. And then I need a y here. So 4x times 3y is 12xy. Minus 4 times 7 is 28. I've already factored out an x, so always double check. 4x times a negative 7 is a negative 28x. All right, let's go to the next one. Now remember, you got to factor out this sign right here. So I'm factoring out a negative GCF. So if we look at a negative 15y and a positive 35, the GCF is 5. So I'm going to factor out a negative 5. So since I'm factoring a negative 5, now since I'm factoring negative, you got to be careful when you distribute to check. Negative 5 times 3y is a negative 15y. Okay? Now, be careful here. Many of you at this point are going to put a plus 7, but be careful, because you're going to put a plus 7 because you have a plus symbol here, an addition symbol. But a negative 5 times a positive 7 is not a positive 35. So, but a negative 5 times a negative 7, a negative times a negative is a positive, is a positive 35. So when you factor out a negative GCF, you have to be careful when you get to this point. Now, since remember I was grouping the first two, and I was grouping the last two, and then notice that these two groups, when I looked at the GCF of each group, they now have a common factor. So I'm going to factor out the 3y minus 7. And so since I'm factoring out 3y minus 7, I'm left with 4x from this group. So put that in parentheses. You put that as a factor. Minus, from here, minus 5. And then again, remember the GCF was 1, so just double check to make sure that this is true. So if we look at these two terms, the GCF is 1. If we look at these two terms, the GCF is 1. So that's your answer. So remember, in factoring a polynomial, you want to make this polynomial look like the product of factors. All right, number 5. let's suppose number 5 was this. All right, number 5, let's suppose we had 7n cubed plus 21n squared minus 5n minus 15. So 7n cubed plus 21n squared minus 5n minus 15. Okay, now, again, I have 4 terms, 7n cubed, 21n squared, a negative 5n, and a negative 15. All those 4 terms, the GCF is 1. Since the GCF is 1, and I have a polynomial with 4 terms, I'm going to try factoring by grouping. So let's group the first 2, let's group the last 2. And again, for us, it will work that way to where the first 2 we're going to group, the last 2 we're going to group, and it should work. There are situations where the factors may have to be rearranged for it to work, but we're not going to have that situation here. Okay, so from the first group, to cover that second group, from the first group, the GCF here is 7n squared. Okay, 7n squared. So since I'm factoring out the 7n squared, I'm going to get 7n squared times n is 7n cubed. 7n squared times a positive 3 is a 21n squared. All right, so to make sure, some of you may put an n here, but if you check it, n squared times n is not n squared, it's n cubed. So you just need a 3 here. All right, now, when you get to that second group, you got to factor out this negative symbol right here. So you're going to factor out a GCF, a negative GCF. So if we look at negative 5n and a negative 15, the GCF of that group is 5. So I'm going to factor out a negative 5. When I factor out negative 5, I get negative 5 times n is a negative 5n. Now remember, this was a negative 15. So if you put a negative 3 here, that's not true because a negative times a negative is a positive, and I need a negative here. So this needs to be a positive 3 because a negative 5 times a positive 3 is a negative 15. And if this is factored by grouping and you're doing this correctly, then these 2 groups right here, those 2 groups should have the same common factor, n plus 3. So then you're going to factor out an n plus 3. Remember, you want to write it as a product, some polynomial times some polynomial. And so when I factor out each of the n plus 3 from each group, I'm left with a 7n squared. Factor out the n plus 3 here, and you're left with a negative 5. All right, and again, just double check to make sure that your GCF here is 1 for each group, for each factor. And the GCF of n and 3 is 1, and the GCF of 7n squared and negative 5 is 1. So there's your answer. You have it looking like this. Number 6, suppose we had 5xy minus 8x minus 10y plus 16. So 5xy minus 8x minus 10y plus 16. So look at all your 4 terms, 5xy, a negative 8x, a negative 10y, and positive 16, and notice that the GCF is 1. So since the GCF is 1, I'm going to go ahead and factor the first group and factor the second group. So I'm going to group the first 2 terms together, I'm going to group the second 2 terms together. Now from that, on the first group, if you look at this, the GCF is x. That's it, just x. So when I factor out the x, I'm going to get 5y, because x times 5y is 5xy, minus 8, because x times a negative 8 is a negative 8x. So that's what I get here. When I go to that other group, I'm going to factor out a negative GCF. And so if we look at negative 10y and 16, the GCF is 2. So I'm going to factor out a negative 2. When I factor out a negative 2 times what term, what factor is a negative 10y? Well, it's a positive 5y. Now be careful here because you are factoring out a negative. So don't put plus 8 because a negative 2 times a positive 8 is not 16. It's a negative 16. So you got to factor out negative 2. So when you do that, you can get a negative 8 because a negative 2 times a negative 8 is a positive 16. Now if you're doing this correctly, remember if you look at these 2 groups again, they should have that common factor right here. And so I'm going to factor out the 5y minus 8, just like this, in parentheses. And when I factor out the 5y minus 8, I get x. And then factor out the 5 minus 8 here, minus 2. And again, just double check to make sure that the GCF of each of those terms is 1, because if it's not, you got to go further. And in this case, since we said the GCF at the beginning was 1, then each one better be 1. So the GCF here is 1, the GCF of these two terms is 1. All right, and number 7, let's suppose this was number 7. We have 7 plus y minus 3x y minus 21x. Now I have 4 terms. 7 is my first term, y is the second term, negative 3xy is the third term, and negative 24x is the fourth term. And so the GCF of 7y, negative 3xy, and a negative 21x is still 1. So all these have been GCF of 1. Now I'm going to group the first two, and I'm going to group the second two. Now, this one's a little bit different because if you look at the first group and all the problems we've done, if you go back to 1 through 6, there was a GCF other than 1. So see, when I looked at the first group, the GCF was 7n squared. When I looked at the first group, the GCF of x. There's a GCF here. There's always a GCF of a polynomial. Here, the GCF is 1. The GCF of 7 and y is 1. That's the only common factor they have, and so that's the GCF. But you got to write it as 1 times this, though, and you're going to see why that's going to be important. So 1 times 7 plus y. So you got to factor out that 1. And so that's going to be important with what we're about to do in this part. So here I'm going to factor out a negative GCF. So if we look at negative 3xy and a negative 21x, the GCF is a negative 3x. Now when I factor out the negative 3x, a negative 3x times y is a negative 3xy, and a negative 3x times a positive 7 is a negative 21x. So always use distributive property to check. So again, if I look at those two groups now, these two are actually the same. Because remember, 7 plus y is the same as same as y plus 7. So addition is commutative. The order in which you add does not matter. 3 plus 5 is the same as 5 plus 3. All right, so the order in which you add does not matter. All right, so I do need to recognize, though, that these are the same. So I'm going to factor this out, and we're going to write it as y plus 7. So I'm going to factor the y plus 7 out. This is y plus 7, even though it's written as 7 plus y. But remember, when we factor out those common factors, there was always a factor here. There was always a factor here. So that's why I needed a 1. I needed that 1 here so I can see this factor. So that's a 1. So I'm going to say 1, and then if I factor out the y plus 7 here, I get minus 3x. And so notice why that 1 was important, because all these had a factor out in front that you put here in your parentheses. Okay, so remember we said the GCF was 1, just verify that it is correct. So the GCF here is 1, the GCF here is 1, and there's your answer. Okay, so in this part of the lesson, the GCF was 1. Now we're about to do another part of the lesson where the GCF is not 1. Well, what do you do if the GCF is not 1? Okay, so that's what we're going to discuss.